collect videos and stuff very close to the event, just to determine where it actually landed. He actually was focusing on security cameras at the time, mainly because security cameras are running all the time, but mainly they get deleted after about a week, a couple days to a week. So if you don't collect them right away, they disappear for all eternity. People rewrite over the videos, or they get lost, or they just get deleted. And so he did a lot of work on actually determining the fall location of this event. And hopefully this actually works, which may or may not depend upon the quality of my laptop. It doesn't look like it will. So this is actually a fireball, or the fireball itself that was seen by a fellow who was basically videotaping planes that were landing at the local airport. A man by the name of Bartlett. Why he was actually videotaping planes and landing at the airport, I don't want to know. But I actually can get this going here.
People have weird hobbies, you know.
Yeah, it was actually on
astronomy's weird.
It's fairly, high in an apartment building overlooking the city. So hopefully I can put this guide up without my computer crashing. Quite a bright event. Certainly this ranks into the Super Bowl-eyed class of things. So this is hitting magnitudes of like 18, minus 18, minus 19, minus 20. Getting very bright. It's casting shadows on the ground. And a lot of people got really excited right away because if you notice right at the beginning, is that you see right on the side here, you'll see like, it looks like there's two fireballs coming down at the same time. Everybody was all excited until they realized that it's a double paned glass window, and so you're actually getting an internal reflection of the camera. So there's only one fireball, so only one object coming down. But you can see that there's a lot of flaring that's going on. It's breaking up into many pieces as it's coming in. So back to this guy. Okay, so again, see if I can get this to work. Oh, Mr. Bartlett. So this is a police car that was actually parked at the side of the road.
Oh, that's a good one.
So, stop to the side, you can see it goes right behind this poor fellow who got pulled over. So this is yet another police car.
This is the best one.
This one got on global all over.
Anna Baxter, a peace officer, and Devin with the
It's going to be a little slow because my computer's slow. I think we'll just turn that down. Because we'll inch our way through the video. So this is just, again, a little camera just sitting on the dash of his car. And it's going to move very slow. There we go. So as he's just driving down the road, down comes the fireball. Right down through some clouds, or seen through some clouds. And maybe this will actually go a little faster now. Some loops. Keep trying. There we go. My computer is crawling.
I feel your pain.
My computer's about 10 years old now, so it's having fun. There's a lot of pictures of this. So you can see, the nice thing about this video is that you catch the fireball very early when it's not too bright. You get a nice side view of it. clouds, you have to deal with that. But I mean, the biggest problem with this video is actually that, the car is moving. So if you're trying to calibrate anything on this, it's really, really tough.
So tell these cops to anchor their cars when these things happen.
Well, I think it was pulling away from some whatever. Anyways, there's lots of videos. I suggest anybody wants to just go on YouTube, have some fun, watch some stuff. Other instrumental records. So just like Tunguska, infrasound was produced. Okay, when this object is detonating in the atmosphere, it's producing shock waves. Okay, those shock waves propagate out, and the waves from this one, the sound produced, was observed in Manitoba, Greenland, Washington, Utah, and here in Ontario as well with our little research array. From that sort of stuff, we can work out, just like Tunguska, an energy estimate of how big this object was. And if you take some assumptions about what its composition likely is to be, and some work on early video reduction, you can work out roughly what velocity it was moving at, so you can actually get an independent mass estimate. Radiometer observations, so this is actually just a little photodiode that is taking sky brightness measurements at sort of kilohertz frequencies in Regina by Martin Beach. And it basically can get a nice view of the light production from the fireball. Fortunately, it too is completely uncalibrated. Anyway, so infrasound, so this was a record that was observed in Manitoba in Lac de Venay. So you see the ambient sound record is over here, and maybe even if I turn this on, I think I actually have this here. Maybe it'll work. It sounds like thunder.
Infra sound now, low frequency, does it travel farther than high frequency sound?
Yes.
I think I thought it would, yeah. That's why it was heard in, the shock waves went to to London, Moscow, and New York. And
Yep. So just like if you ever have like the neighbor's kid driving in his car, he's got his stereo turned up, and all you hear is as he's driving by is the thump 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 of bass going by. It's because the low frequencies don't attenuate in the atmosphere very easily. They don't get scrubbed out. You never hear the words of the song because they're at much higher frequencies, and they get
when the tsunami came, the elephants were able to hear the infrasound.
Same sort of deal. The really, really low frequencies, and we're talking, only a few hertz here. I mean, very, very low frequencies, and those kinds of frequencies can propagate for hundreds and thousands of kilometers. So that's why stuff like this can actually be detected from such remote areas. So this is just sort of ambient levels here. You can see it's a really big signal here. Boom. Okay. This is the signal that was actually observed here in southern Ontario. So this is sort of the same scale of background noise that we saw on the other one, but you just get a little bump. So it was just a little bump here in Ontario. Radiometer records, so this is, again, sky brightness. And so you can see right around the time of the fireball, you've got this wonderful little light curve. So you see that each one of these little spikes here is actually a fragmentation event. So this is your object breaking up in the atmosphere as it's entering. So we little flare, flare, little flare, little flare, little flare. And so the nice things about this is that if you can get a video record that will give you another independent estimate of where along the trajectory these flares are occurring, you can say this is a potential release point for meteorites, this is a potential release point for meteorites, and work your way down the trajectory to determine where your meteorites should fall. So the size of the object, kinetic energy estimates from the infrasounds are somewhere on the order of 0.4 kilotons of TNT, equivalent energy. So it's about half to a third the size of Tagish Lake. Comparable in size to Park Forest that fell in 2003 over Chicago. People might have heard or seen things about that. Meteorites falling in one of the communities south of Chicago. Meteorites hitting people's roofs and impacting cars and all kinds of stuff. So similar type event to that one. So nice little equivalent math. Those interested, initial velocity estimates of the meteor from very early on, and this is going to be refined, but it seems to be that it was moving relatively slow meteor-wise at 14 kilometers per second. So if you take, your first year physics, you say the kinetic energy is equal to 1/2 of your mass times your velocity squared, and you stick in your value for velocity, and you take your energy estimate for kinetic energy, you work out a mass that's something on the order of 10 metric tons of material, or on that order, was the size of the original one. If you make some assumption that, you have a spherical meteoroid, and it has a typical stony type density for regular stony meteorites, you work out that the object size is something on the order of 1 meter in radius, so that's something the size of a desk, a good sized office desk, is impacting the atmosphere and producing lots of meteorites on the ground, as we'll find out. So where did it go? So Allen and company refined the fall location of the trajectory after about a week of in situ observations, and he's worked out that basically it's moving north to south over Lloydminster, Saskatchewan, relatively steeply at about 60 degrees from the horizontal, so it's coming down pretty steep. And the fall region is actually located 30 kilometers south of Lloydminster. So if you look on a map of the prairies, so here's Manitoba, Lac du Bonnet, where the sound was produced there, the first one is that little triangle. Lots of eyewitness seen around, and if you look at that little red arrow there, on this scale map, that's about the size of the trajectory. So from beginning to end, it's a very steep. So there's, you can't really see the third dimension there, but the little star also marks the rough location of the fall zone. So right sort of midway between Saskatoon and Edmonton. The initial find, again, Allen and company were interviewing people around Lloydminster area and around Battle River, and of course they decided that we've got a good idea of where it fell. Let's start looking one day, and so they were driving around, and because of Tagish Lake and other similar falls, Allen's experience said that black rocks are easy to find on frozen ponds. Okay. So, and it's very obvious that, if you have a rock sitting on a frozen pond, rocks just don't fall from the sky, in everyday Earth sort of sense, unless somebody picks one up and throws it on it. So it's likely going to be a meteorite. If it's frozen on the pond, sitting on top, it's probably a meteorite. And his grad student, Ellen Milley, spotted a black rock on a frozen cattle watering hole, just a little dugout. From the car, she saw this. I'm amazed that she saw it at speed. But she got it, or they stopped the car. Ellen decided to stay in the car because it was like minus 15 out. She was cold. Allen went out to investigate and confirmed that yes, indeed, it was the meteorite they were looking for. And while Allen was getting his measurements of where it actually was and taking a good look at it, Ellen decided to walk around the pond and found 9 more fragments on that same cattle pond. And the pond itself is not very big. Maybe 100 meters, maybe about the size of this room. The size is the size of the pond. And he found 10 meteorites on that little pond. So that kind of density, so if you've got 10 in that little area, and you look around you and you see nothing but open fields, you can imagine that, that's the density of meteorites you've got. There are thousands of meteorites in the area. So of course, because we're all very public about things, the media was alerted of the find the very next day, and because of the media, everybody wanted to be involved. So there was a general call for searchers later. There's a picture of Ellen.
Who owns it? The landowner?
The landowners own it, yes. So in Canada, if a meteorite falls on your land, then it is yours. If it falls on the Crown's land, so either on a lake or a river or a provincial park or on the road or on a railroad, it's finders keepers. So again, here's Ellen. This is the size of the pond, so you can get a rough idea of the size of the pond there. The meteorite is actually located at her feet. And there it is, right there. So the initial fragment was something on the order of 200 grams. And you can see that Ellen became very rapidly the star of things. And if this actually works, there he is. There we go. Let's see if this works. I'm being very multimedia-ish today.
I'm Alan Hildebrand. I'm a planetary scientist at the University of Calgary. We are in Buzzard Coulee, Saskatchewan, southeast of Lloydminster. And behind me is a pond that has 10 meteorites from that white fireball on November the 20th. This pond behind us is something like a half hectare. It's maybe 100 meters long. I don't know the year exactly. Ellen found 10 meteorites in this pond. That says about 20 meteorites per hectare. There's 100 hectares in a square kilometer, so that's 2,000 meteorites per square kilometer. I mean, the number of meteorites here is in the thousands. Meteorites, say 10 grams of iron. I've been investigating fireballs for 15 years, and this is the first time it worked out that we were able to predict where the meteorites would fall and go into the field and be able to find them, although Ellen Milne got the brass string for finding the first bases.
My name is Ellen Millie. I'm a master's science student at the University of Calgary. We stopped the car, tested the ice, tentatively climbed this. He looked at it, he got up and said, yes, this is definitely a meteorite. Well, this is the first piece that was spotted and embedded in the ice here. It has the typical fusion crust, and it's got kind of the unusual shape for an earth rock. You can see some of the kind of weird shape that it gets from being melted in the atmosphere.
Well, I'm Ian Mitchell, and at this point I'm not sure what to think about.
This is the landowner.
It's kind of exciting. I don't know. I mean, souvenirs, research, sort of thing. If I find a great big one, I can guess I'll set that up.
So you can tell this is right after. I mean, Ian had been told, they had gone to Ian's house and said, I think we found meteorites on your pond. You might want to come out here and take a look. Technically, they're yours. So, of course, the media get out there and they're like, so what are you going to do with all these meteorites? He's a typical rancher out there. He's the rocks, right? What am I going to do with a rock? I don't know. Souvenir. We'll give them to the researchers for a bit. And as we'll see, that they did find very big pieces too.
Saskatchewan Nobel Prize winner.
So the fall area just tends to happen that something like 90% of the fall area, or presumably what is the fall area, we're really not sure how big it extends now at the moment, but is basically owned by two brothers. They own something like 90% of the fall area. So conveniently, you only had to deal with really two people to do a lot of the ground searching themselves. When you've got thousands of meteorites on the ground and they're going at $15 a gram, that's a lot of oil wells, I guess, in their terms. So the ground recovery, so you can see from the video, you're talking thousands of meteorites over several kilometers in size for the fall area, that is. So there was general need for people to go in, and so Peter Brown was contacted by Alan, and he grabbed me and Phil Mccosland, as volunteers. We got a phone call early in the morning on the Saturday. They had found the first pieces on the Thursday. The media was contacted on the Friday. The ensuing chaos of media interviews totally ate up Friday. So we came in on the Saturday, first thing in the morning. We were basically in Lloydminster that evening, and the searching really began in earnest on the Sunday. So it was, we were the Marines. We were dropping into the zone to keep things going, because Alan, well, of course, being the organizer, he wanted to get lots of volunteers out there. And so to do that, he actually had to get back to Calgary, start organizing things, and it would be better to send big amounts of volunteers into an area where meteorites are. And so it was our job to actually go in, reconnoiter things, check out where are the densest areas that a good large search group can pick up lots of meteorites very, very quickly. So this is where we stayed. There was actually, remember this is this is Lloydminster, and remember the fireball came right over Lloydminster. So Alan found this hotel because they had given him a security camera video that showed not the fireball itself, but the shadows that the fireball produced, as it went over the hotel. And so the staff got to know Alan very well, and so they gave him a discounted rate, and so that's where we stayed. So, anyways, so just for context, so this is what the fall area looks like. Fairly rugged kind of country, but not too bad. Lots of hills and dales. This itself is just a little tiny valley called Buzzard Coulee. Okay. Buzzard is a very small town that's located to the north, and there's a little creek down in the middle of this coulee, which I have no idea the name, but it's probably Buzzard something. And Meteorite Pond, so in the video you saw Alan standing beside it. That's Meteorite Pond itself. You can see how very, very tiny it looks in comparison to the area. Every spot around here in this, that you can see probably has a meteorite on it of some size. Okay? And you can do the math. 10 were on that pond. Start adding up the number of kilometers that are there. So just another shot. You can see that when we got up there, we're on top of a ridge and looking down, and you can see that we're not the only guys out. There's certainly other people wandering around looking for stuff at this point. I mean, this has hit the media and the real energetic searchers that already come in, and they were basically combing the roads and walking along the railways looking for fragments. There were lots to find. So again, looking off to the south, down the coulee. So this is the ridge that we're standing up on, and the coulee wraps up and around it. And again, lots of little pictures. So these little suckers that you see here, these little structures, are actually oil batteries. So this is basically storage for the oil they're pumping out of the ground. And there's lots and lots of these around the area because it's oil central there. So we were trying to look at as many of these areas as possible, mainly because we don't have to deal with a lot of grass or anything like that. We've got basically a nice groomed road where meteorites could fall, and you can just look and pick them up off the ground with your pilot. Very easy, relatively easy to spot, easy spotting area. We kept looking around though for batteries that showed any signs of impact. It's that there's enough of these batteries out there and enough meteorites falling that you have a good chance that one took a good whack. Didn't find any that actually had a whack in them. Same thing with the cattle too. Kept looking for the cow that had a really big bruise on the side of it. Because you definitely wouldn't want to be in that area when this sucker was falling, because there was a good chance that you could take a look and get hit. So this is sort of what we were searching on. This is very short, dry, frozen grass. Okay, it's been stomped down by the cattle. You can see the cattle's leavings behind. A couple cow pies up here, very old cow. You got to really know your cow pies. Okay. The various stages of cow pie, growth and age, I guess. So these are very, very old cow pies. Newer cow pies look much more brown. So you can see that this is very shortcut grass, so you can walk around, and you would assume that anything of any size you should be able to spot from a good fair distance. Excellent searching conditions. And this is just the top of the ridge, and you can see that it's relatively flat. This is the very, very nice searchable area. And of course, the first thing we did, because we didn't know what we were looking for, is everybody decided we'll take a direction. I'll walk that way, you walk that way, and we'll do this little random walk. And we'll look for meteorites. Well, we did, and we wandered around. And of course, the first one that was found by Ellen. who had actually seen a meteorite before. And so this is just the first shot of our first fragment found that wasn't on Meteorite Pond, which is the name that has been unofficially given to that little cow dugout. So you can see from the scale, you're looking at something that's about 1.5 inches in diameter, very good size. I think it turned out to be something like 300 or 400 grams. And so once we actually got a good look at it, we could find more. Because now you have sort of what, context of what you're looking for. You've got a good idea of what these things look like against the background. And so this is my first piece. Ever found, never found a meteorite before, despite lots of time working with meteorites and fireballs and stuff, so it was my proud moment. And there was nobody around for me to share it with, so I got lots of pictures of this meteorite, but I never got a shot of myself with the meteorite, which I think of later as that was kind of stupid. I should have put the camera elsewhere. Yeah. Anyways, again, good size. So here's Phil Mccosland. He's sitting right beside meteorites. You can see his little indexed card there for scale, and the meteorite is right there. And you can see this little broken off piece. The nice thing about these meteorites is they've got this very nice, pristine fusion crust on them. They're very, very black and satin kind of color. But if it's broken, the interior is actually very light gray. Okay, so you've got this excellent contrast if you find a broken piece. And we're wandering around this field for a little while. And basically every once in a while you'd see what is effectively a museum quality piece of meteorite sitting there in the field just waiting to be logged and cataloged and everything else. And so this is what we did. And so this is again another piece. This one actually did penetrate the ground. You can see it's not a crater, it's a hole. This is what we named this piece actually Snaggletooth, because that's kind of what it looked like. It looked like sort of an inverted thumb. And the reason it actually penetrated the ground rather than just actually hit and bounce and just sit on the top is that it landed sort of thumb down, so you actually had a good chance to penetrate on that as well. Not technically a crater.
So you don't actually pick up the meteorites as you find them?
The standard procedure that we took is that, if you found one, you got excited, but then you calm down and you say, okay, well, here it is, and you take your GPS and put it down beside it. You put some sort of scale, for an in situ photograph of this is how we found it, and then you basically throw on your medical glove or whatever, pick it up, put the coordinates on the bag, on like a Ziploc bag, freezer bag, put it in the bag, seal it up, put it in your pocket, keep going. And it's just all we're trying to do in this case is that, one, we're trying to recover stuff that's pristine. The least weathered, the least altered material was the entire purpose for us to be there. And so you didn't want to contaminate it with the oils from your hand and this stuff. So we're trying to be as clean as possible with this stuff. So as eager it is as you want to just grab it and turn it over in your hand and stuff. You kind of have to keep your distance, I guess, and keep your composure. But after a while, there were so many meteorites that were being found. It was like there's another one and another one and another one, and after about the 10th or 12th one, you're kind of like, it's a rock. So the standard procedure is just tag them and bag them as quick as you can.
But what about the policy that it belongs to the person who owns the land?
The policy is still in play. We are on the landowner's land by his permission. We have his permission to be on his property. We were the only group that was allowed to be on their property. But everything we found, it was already explained that this is the landowner's. And eventually, a lot of the material that we collected, we were going back to the University of Calgary for analysis and cataloging. But eventually, that is all going back to the landowner. It's just, it was found on his property, it's his property. We're not trying to, take his property away from him. All we're really interested in is, what can we learn about the fall area? We want to know masses, we want to know locations of where they've fallen, so we can map out the strewn field so that we can understand how this material fell. Because if we can understand the way this fell, then we can go to another firewall, and we don't know what happened, model it, and get a better idea of, you know, where should we be looking for pieces, you know, what kind of pattern should we see. This one actually, we're suspecting, because this was sort of a north-to-south trajectory, the winds were very, very strong in the, you know, in the atmosphere at the time, and it was blowing from the west, so you had almost a perfect crosswind. And so we're suspecting, though we haven't actually seen it yet, is that a lot of the lighter material, smaller fragments that get decelerated very easily, can get caught up in the wind, actually gets twisted off to the east. And so the strewn field sort of should have like this bend in it where a lot of the lighter material gets, you know, dragged off to the east, just from the westerly winds. We haven't seen that yet, but that's what I suspect we'll find. Yeah.
I just have a curious question. Suppose in the future there's a return sample mission from, say, Iris or the asteroids with rocks in it, and it came down on this property. Would he have ownership of that too, or would that be more for? That's a good question.
If it was a recovery mission?
Recovery mission.
Well, for
Return
one,
sample mission.
usually recovery missions will try not to land it on someone's property.
They won't try it.
I would say,
The
if they're
helicopters
going
come in
to,
with the men in the black
Yeah.
suits, and they retrieve what's theirs.
yeah, I
Yeah.
mean, it's, you know,
You
if you're
want to argue
doing
with their
a detailed
rifles?
mission like that, and you're gonna land it in somebody's property, you're probably going to, in advance, go talk to that person about, you know, who owns what.
Yeah.
You
But
don't own satellite.
For the most
bits.
part, a lot of recovery missions will go to remote areas to land their stuff. I mean,
Yeah.
they'll go to the Nevada deserts, or they'll go to the Utah salt flats, or, you know, somewhere that, you know, is not on somebody's property.
And if it comes down by accident, you still don't own it if you're the
Yeah.
landowner.
No, you don't know.
So, again, once we actually decided that, you know, we knew what the heck we were looking for, we decided not to do this random walk stuff. And so instead, what you do is just, everybody gets in a line, you know, sort of arms distance apart, you stand in a line and you walk the field, just back and forth and back and forth, and you just keep your eyes on the ground in front of you. And eventually, because the field is, you know you're in the middle of a field that has lots of meteorites in it, just eventually you're gonna walk right into one. So literally, you would see it just as you're about to step on it. And it was, you know, you would wander around and be looking and looking and looking, and then you're like, oh, there's a meteorite. And you stop that, step back, tag it and bag it. And then you just continue this over and over and over. So it's the same sort of procedures that you use if you were, you know, a police force looking for a murder victim. You know, you get lots of people in a big long line and you walk the fields. Same standard search pattern. So of course, we were all very eager at the very beginning, and we found lots of meteorites. So by the end of the day, certain members of the party were very, very tired.
How many cow pies got back?
No cow pies got back. You actually got a very good inkling of what a cow pie looked like and what a meteorite. Although there were several instances where you swear that cow pies have look very close to fusion crust. Just have that right kind of color, right kind of size.
The house came from outer space. So,
Which had the more random distribution, the cow pies or the meteorites?
Certainly there were a lot of cow pies. So we weren't the only ones looking, so this is just a couple folks that we
Notice how
met.
excited Peter Brown looks.
And so, yeah, you've got Alan. Alan hadn't quite left for Calgary yet. I mean, people were walking the roads, and so when we got back at the end of the day at lunch hour, we'd be driving back through, you know, all these people searching for meteorites along the road. Where are you guys looking? You know, have you found anything? Da, 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 da. You know, it's being the official research team. We were kind of like, you know, we don't really want to tell you where we're finding things because it's on the landowner's property, and you know that would be trespassing for anybody else to look on there. And certainly, poaching was going on. I mean, certainly there were people wandering in areas they shouldn't have been. But I mean, we weren't there to enforce the law, but we were certainly going to abide by it. So the current record holder
wow.
is a 13-kilo mass, which is about the size of a watermelon. Okay, This was found by a fellow who, after seeing the news reports, had gone up and searched around the area, and he spotted it from the road. It was just off, sort of into a field, which happened to be on the landowner's property, and he wandered over and he saw it. It was like, great, I found one. Picked it up and promptly went to the local bar where he showed it off to all his friends, and everybody got the picture with it. And of course, news got out, and we had to go track him down and find out where it was specifically. Found it, and after 3 or 4 stories, we eventually got back to where he found it, and it was returned to the landowner. And this is where we are when we're actually holding it.
Now remember, this is selling for $20 a gram.
Yeah. So
Do the math.
so you're looking at a museum quality piece. You're probably looking at $100,000 easy, plus, sitting in the palm of your hand. So everybody wants to get a picture with it, and so everybody did. It was a very, very nice piece, I must say. I've never had a meteorite that big in my hands, ever.
Was that an iron?
No, this is stony chondrite. So very, very ordinary.
H5, H6.
Yeah, very, very ordinary type of stone. It was magnetic too, very magnetic actually. So it's an H chondrite for certain, and I guess I shouldn't be able to say it at this point. It's not quite public yet, but you're looking at something that's probably like an H4 type chondrite. So, I mean, not terribly unique in any sense. I mean, there's thousands out there already, but it's on the way. So that was the Sunday. So come December 1st, Alan disappeared for Calgary, and Peter left for Western. He had to get back because his daughter was being tended by his mother, who was sick at the time, and Peter's name was Mud already for leaving. So the search team shrank to 3, just Philip and Ellen and myself. And so again, it was recon for the best possible sites for when Alan returned with the much bigger group later in the week. And that's a joke that only Western people will understand, I guess.
We got that email.
Oh, did you get that
We
email?
got the
That's
email.
a crazy email.
We got the email.
Yeah, UWO is not UWO anymore, it's Western. So this is just sort of, again, different shots of the field, us taking measurements, us walking the field. Spot the meteorites here.
Like a water bottle from space.
Exactly, there's the meteorite right there, right beside the water bottle, because it's right there. That shows, gives you a good idea. I mean, it's sitting in the middle of the field, conveniently right next to nearby cow pie. A very old cow pie. It started to turn kind of white and gray, so a little easier to dissociate. So another little "Where's Waldo?" Well, where's Waldo? Where's Waldo?
Just to the right of the center.
Yeah, there's actually no meteorite in this picture, but there is one there. So this was actually spotted. This is a 1 kilo fragment, 1.3 kilos. Again, Ellen spotted it from the car while it was moving. How she can do this, I have no idea. We must have driven by this thing about 3 or 4 times, and just, not a clue. She just spotted it from the car one day. So, good sized fragment. And of course, we weren't the only ones out there. There were lots of calves and horses. Okay. And so here was our little 4 hominid crew. We were helped out by Mel from Saskatoon later in the day. But that's not the end of the day, because after we had gone back, because we were doing a search, we wanted to be in the goods with the landowners. So every day we would go back and we would talk to the landowners about where we were, what we had found, what we were planning for the next day, and whatnot. And so as we were moving from one brother's house to the other brother's house along the little public access road, we came upon these 2 fellows who were digging something out of the ditch. And we, being as inquisitive as we were kind of like, okay, we're tired, but we'll stop and find out what they're doing, because who would be digging in a ditch in the middle of a meteorite-strewn field, if not meteorites? And this fellow by the name of Warren Wiley, who was on the left, and his good friend Roger Forsyth on the right, picked up this large rock. And he sort of asked us a question. He's like, is this what I think it is? I don't have any idea. I have this rock in my pocket that I've been hauling around all day, which was just an ordinary piece of earth limestone. And he's like, is this a meteorite? And so he had pulled it out of the dirt, and so it was completely dirty. And it had landed face down and had been level with the ground. It had punched a nice little divot into the ground. And so we pulled it, put it into the car, and put it under the car's lights. And sure enough, nice black fusion crust, nice thumb printing pattern on the surface, definitely a meteorite. So he found the second monster fragment, which is currently weighed at something like 7 kilograms. It was very interesting for that 15 minutes as we tried to contact one of the landowners because we didn't know what the actual size of public property on either side of the road is, what the allowance was. So it could have possibly be one of the landowners, and we really didn't want him to walk away with it. So we got a hold of one of the landowners, and he came along, and he was like, yep, that's public land. So he was quite surprised. He had actually been out all day looking for just a small fragment to take back to his son, I guess. And he came back with the second biggest fragment that we found so far. I mean, he was just very, very shocked. And this is just, again, Ian and his son, Kristen. And we had asked, actually, Ian's, because we didn't want to cause a fuss. And, I mean, he had been out all day, and we just don't want to make too much of a mistake. So we'd asked Ian if he would mind bringing a small, fragment with him in his pocket or whatever. And so just in case we had an issue of who owned what, we could do a trade of sorts. He was a relatively easygoing fellow. So certainly he would have done the trade if asked, but it turned out that he got to keep the big sucker that he found. So he was very, very happy. And so we were very, very happy too, but we were also very, very tired. So, we were not quite done yet because the next day the big group came in. And so Alan came back with 13 more people, and we started doing searches, and we had RASC members from the Calgary Center, and we had a lot of undergrad students, some faculty members from the University of Calgary that also came up. And everybody had been told by Alan that, there's lots of meteorites, and you're going to find meteorites, and da-da-da-da-da. So everybody was all eager to get out there right away, first thing in the morning. Let's get going. But of course, we had to get everybody under the same page, and so we had to tell them that even though you're finding these things, you don't own them. You're here under the university's directions, and anything you find is the landowner's property, and you can't keep it. So once we got that all the ground, the lines drawn in the sand, I mean, everybody sort of got along fairly well. And controlled chaos ensued as people are trying to find stuff in the field. And so our lines got longer. We follow the same sort of standard procedures. You'll note that we have these wonderful colored jackets now. It was hunting season. Okay? So we figured we make ourselves even bigger targets and put some nice bright colors on it so we are easier to shoot. And you can see now that over the night, a little bit of snow had fallen. And so this is a warning flag right now. It's that, a lot of the smaller fragments that we had found, the 10, 20 gram size stuff, little tiny stuff, is now impossible to find. It's now completely covered in the snow, and you're just not going to recognize it anymore. So you're really only reducing yourself now from the entire field down to the much bigger fragments that stand out about around the ground. So
could they not be found with metal detectors?
No, unfortunately, unless it's an iron meteorite, metal detectors don't work very well. The way metal detectors work is that they induce a current in the object itself. And so if you've got something that's metal, you have a very large continuous piece of metal, you can induce a nice large current in it. So a piece of wire or a screw produces a really big signal. Although there's iron in these meteorites, it's disseminated throughout the entire body itself, like the rock itself. It's not in any small lump of iron in the middle or something like that. And so you just can't build as much of a current in it, and so you just don't get a good signal. I mean, if you went over a meteorite with a metal detector and you turn the gain up on it really, really, really high, yes, you'll get a signal from it. But, you know, you'll also, for every meteorite you find, you'll get bottle caps and wire and screws and nuts and bolts galore. And quite honestly, you're easier to use your eyes. I mean, they were easy enough to spot.
Now, you said they were highly magnetic though, right?
Yes.
So could you not use little compasses that are going crazy?
They are magnetic in that they have iron in them, and iron will attract a magnet. They're not magnetic in the sense of they have a permanent magnetic field in them. Although you can, and people did, use magnets on a ski pole, walking the roads, and people with magnet brooms for picking up screws and nails and stuff like that in like a shop. I mean, people were using those on the roads and finding meteorites because the meteorites would just stick to the magnet. So I mean, magnets work, but really magnets only work for the small stuff that you're not going to easily recognize with your eye. I mean, much bigger stuff, your eye is the best detector. It's just the way it goes. So the big line search continues. Lots of people, and of course it was, looking for meteorites, black rocks, and white snow, which is also very easy to do once you know what you're looking for. And the line continues again, and of course it, I think, was bound to happen eventually. I mean, statistically, it was bound to happen. There's lots of cows out there. There's lots of cow pies. Eventually, there's going to be a meteorite that is nearly near on a cow pie. And so, if you can spot the meteorites on here, and where's Waldo? He's right there. So if we zoom right in on that guy, there's the meteorite versus the cow pie. Yeah, Ellen found that for me. I was very happy. I was very, very happy to have to log that one. Lucky for me, the actual cow pie was frozen, so it wasn't so stinky, it wasn't so gooey or whatever. It's relatively easy to recover. So, unfortunately, the snow continues to fall. Every night we were getting like a centimeter of snow, which meant that, a lot of the areas that were in the lee of the winds, where the wind would break, the snow would accumulate, and it just get deeper and deeper. And so all the areas that were, nicely out of the wind, because you're looking at temperature like minus 15, minus 25 in the wind chill, minus 30. And so you couldn't go to the nice sheltered areas anymore. You had to stay in the wind blasted areas. So the search got much, much colder. And so we had to bundle up. And we continue, and you can start seeing that the snow is accumulating such that you're getting drifts over the fragments, starting to get buried, and it's getting much, much colder. And this is a picture of me freezing my tail off, logging in another fragment in the snow, and some more in the snow, lots in the snow. And it gets dark, and you're still finding them in the snow. And this is one actually that Phil found after we had sent our entire crew back to the cars. It started to get really dark, and you're in an open field with no lights, and you don't want to stick one of your car's wheels into a gopher hole and not be able to get it out. So we sent the entire crew back to the cars to warm up, and Phil was going with his GPS to go mark the areas where we had been, so marking the corners of our search area for the night. And literally he decided that, where I'm not going to walk over the same area that people have already walked over before. And so he walked 3 feet away from the last person's foot marks, and sure enough, walked right into a nice half-kilo fragment. It was like, wow, that's great. So he marked it down with a flag and went to go mark his other position, and he came back and he walked into another fragment. So right at the end of the day, when it's getting the coldest in the darkness, he's finding these things. So anyways, we were nearly done at that point. The next day it started to really snow, and things just got just to the point where you just couldn't find anything. Even the biggest stuff got buried. And so at the end of every night we had to weigh our fruits of our labor. So this is a particular piece that was found by Phil. So that was the one he was actually leaning over before. This tends to be very, well, this particular one was oriented And so it's actually sitting with the oriented side down. So it's, by oriented, I mean it, when it was moving through the atmosphere, it had only one face to the oncoming airstream. And so you got this very sort of Apollo capsule look to it. And you can see a little bit of, you're seeing the back side of it here. And so you're getting molten material that's actually splashing back around the back side of the meteorites. And so you get like small rivulets of molten material that start sliding around the back edge. And so you get this sort of streaky pattern on the back side and a nice little rim that runs around the edge. So it's a particularly interesting piece. And there's Phil holding his prize at the end of the night. And there's Phil falling asleep at the computer, trying to keep awake as we catalog everything. Poor sleepy postdocs. We've been doing this for a week now, and you're working 16-hour days and 4 hours of sleep, and eventually you're just falling down. Even Alan was tired, so poor old Alan. And eventually you just had to pack up. I mean, it just got so much snow that the recovery effort was effectively over. There's no more recovery material, and you're on your way out. So here's our good recovery team for 3rd and 4th. And for the 5th and the 6th, us by Meteorite Pond again. So we had good time. So what was the final tally? Well, the final tally was that more than 70 individual meteorites themselves were found and recovered before the snow got too deep. The meteorites, like I say, were greatly magnetic and stony, and from the initial views it seems like it was an H5 or an H6, very common ordinary chondrites. Now it seems like that may be a little, probably more like an H4. Video calibration and classification, all those things that let you determine the meteor's trajectory and velocity, all need to be done. So now that winter is set in, it's exactly what Alan's going to do. He's going through and going to be calibrating all this stuff so we can work out what the fireball, what its exact trajectory was, what its exact velocity was, so we can work out what its orbit was before it hit the Earth, which has only been done 9 times beforehand. So this will be the 10th if we can do it. So very interesting in that. So we'll have a meteorite where we actually know where in the solar system it came from, which is a very unique piece of information. So that is effectively the end for that.
When are you going to